This is 11E. And I think once you do a couple of these problems, they're not going to bother you anymore. They're not really difficult. It's just a bunch of steps. So we have number 1, x bar is 68, and the SDX is 2.7. And y bar is 63 with an SDY of 2.5, and we have an R value of 0.25. That's a pretty terrible regression correlation coefficient. Right? This not very correlated, but there is a positive trend. So letter A, what percentage of the women were over 5 feet 8 inches tall? How many inches is 5 feet 8 inches? 68. So I'm going to take, nope, these are Y values. The average for men is 68. So this is men and this is women. So 68 minus 63 is 5. So 5 inches is equal to 2 SDs. So we just did 5 divided by 2.5. Now, if you think about this, you don't even need to do shade norm. Why not? We know the normal curve. If we go left 2 and right 2, we get 95%, which means 5% in the total of the two tails. So the right tail would be, this over here is 2.5%. So the answer is 2.5. It said over. It says what percentage were over 5'8". So that would be 2.5. Only 2.5% of the people are over 68 inches, the women. Okay. And then B, of the women who are married to men of height 6 feet, what percentage were over 5'8"? So we're going to assume normal. Oh, and it's 0.25, so we're probably looking at something like this. Right? We have our line running through there, and our X bar is 68. And somebody who is 6 feet tall would be 72. So I want to go over here to 72, and I want to make a vertical strip. And I just want to look at that vertical strip. Okay? So we need the new average. How far to the right do I go to get to 72? 4 inches. So 72 minus 68 is 4 inches. Divide that by 2.7 and I get 1.48 SDs. Right? Now I need to go up 1.48 SDs times R. So 1.48 times 0.25 is 0.37 SDs. So we're going to go up 0.37 SDs. What is that in inches? I need to multiply that by the SDY. So times 2.5. And it's 9 1/4. Or sorry, not 9 1/4. It's almost 1 inch. Right. So I'm going to cut this off at 25%. And my original X bar was 63. So my new X bar, my new Y bar is 63.925. No, I didn't go. Okay. So this point right here is 72, 63.925. Okay. Now I need the SD of this strip, which is easy. The SD of the strip is 2.5 unless r is less than 1, and then it's smaller than 2.5. How much smaller? It's always the square root of 1 minus r squared smaller. So we take the square root of 1 minus 0.25 squared. Oops, that didn't work. 1 minus 0.25 squared. So the new SD is 96% of the old SD. So I multiply this by 2.5, and the new SD, so we would call this SD, the SD when x is equal to 72 is now 2.42. Okay, but that's not the answer. That's just the SD of the vertical strip. What do we want? We need a z-score of the y values to get a percentage of how many of the women are over 5 feet 8 inches. Would we expect that to be higher or lower than our original amount? So when we solved A, we said 2.5% of the women are over 68 inches tall. Well, it's more because why is that number going to go up? No, it's because what group are we looking at? Tall husbands. So we are looking at tall husbands, so we would expect more of those wives to be tall. Right? Okay. Not a whole lot more because our R value is so terrible, but we would expect more of them. Just like our SD dropped from 2.5 to 2.4, we would expect the percentage to go up by an equivalent amount. Does that make sense? Okay. So we have this SD of 2.42 right here. So I draw my normal curve, and well, just draw my curve. My y bar is 63.925, and I want to go right how far? No, I want to go right. The question says the wives are over 5 feet 8 inches. 68 inches. So 68 minus 63.925. So 68 minus 63.925 is 4 inches. Now I need a z-score. Divide it by the new SD of 2.42. So what does that tell me? That's the z-score, so I need to shade norm 1.68 to 5. I'm going to clear my draws this time. So 1.6, what was it? 1.68 to 5. And we would expect the answer to be bigger than 2.5, and we end up with 4.6. Okay, let's do another one. Number 2. Okay, so we have fathers. X bar is 68, and the SDX is 2.7. For sons, Y bar is 69, and the SDY is 2.7, and R is 0.5. Okay. What percentage of the sons are over 6 feet tall? So 6 feet would be 72 inches, right? So we want the sons greater than 72. So I take 72 minus 69 equals 3. Divide by 2.7. So 3 divided by 2.7 gives me a z-score 1.11. Shade norm. So we're going to do shade norm from 1.11 up to positive 5. And I get the answer to this question is 13.3. So 13.3%. That's the answer to A. Okay. And then B says, what percentage of the 6-foot fathers had sons over 6 feet tall? So now I take my not very good football, okay, and what I found the first time is I went up here to 72 and I drew a horizontal line and I found that area, which is 13%. So that's actually kind of a terrible, right there. That's what I found the first time, right? Now, I want to go over, here's my x bar 68, I want to go over here to 72 and make a vertical strip, and of that vertical strip, where this runs through the middle, how many of those people are above there? That's the goal. So, I need to find the new average. My old averages were here, I need to go right and I need to go up. How far to the right am I going to go? Well, I start at 68 and I end at 72. So I go right 4, which is equivalent to 1.48 SDs. Now I need to go up 1.48 SDs times 0.5. So 1.48 times 0.5 times the SD of 2.7. Oh, I didn't multiply it. 0.74 times 2.7. Almost 2, which makes sense, right? They have the same SDs. So if I go 4 inches to the right and the R value is 1/2, I'm going to go up half of 4, so 2. So I go up 2 inches. So my new averages are 72, 73. Right? So I went right 4 up. Oh, sorry, you're right. 71. There we go. Okay. What is the SD, the new SDY for that vertical strip? Well, it's going to be 2.7 times the square root of 1 minus 0.5 squared, which we would expect a number smaller than 2.7 because we're looking at a vertical strip. So, square root of 1 minus 0.5 squared. So our new SD is going to be 86% of the old SD. We times this by 2.7, and we get 2.3, which we expected. The old SDY was 2.7, and the new one needs to be smaller than that. Okay, so I now have the SDY when x equals 72 is 2.33. And the question says, what percentage of 6-foot fathers had sons over 6 feet tall? So this is the SDY for dads that are 6 feet tall. How many of those sons are over 6 feet tall? Well, I have a new y bar, 71. So we want to do 72, which is 6 feet tall, minus the average of 71 is 1 inch. Divide that by 2.7. Oh no, sorry, 2.33. And I get that, which is, that's a z-score. So I need to shade norm from 0.43 to 5. And that will tell me, so what I've done is from 71, I've gone to the right 1 inch to 72, which gives me a z-score of 0.43, and I want the shade norm to the right, and I would expect an answer that is larger than the original 13.3. So clear draw, shade norm, 0.43 to 5. We end up with 0.33, 33%. Okay, I want you to try the next one, um, and then I'll turn the video on and finish it. All right, number 3, we have heights. We have x bar equaling 68 with an SDX of 2.7. And then we had forearm lengths, y bar equals 18 with an SDY of 1, and my R is 0.8. Can you determine somebody's height from the length of their forearm? Pretty close, 0.8. That is a very high correlation coefficient. You just measure their forearm length and then you find the equation, right? The slope of the regression line. You just plug you would plug the forearm length in for the y value and solve for x. Okay. And we want to know what percentage of men have forearms that are 18 inches long to the nearest inch. So basically, we're looking at the histogram of all y values. The average of those y values is 18. We're not looking at the x's. We're just looking at the forearm lengths. So we want to know how many people were labeled 18 inches. Well, the only way to be labeled 18 inches to the nearest inch would be if you rounded from 17.5 up and from 18.5 down. So if this is 17 and this is 19, the only people we're concerned about are these people from 17.5 up to 18.5. If you're below 17.5, then you got rounded down to 17. If you were above 18.5, then you got rounded up to 19. So all of the measurements were given in the nearest inch. Okay? So, how far to the right do I need to go to get to 18.5? 0.5. So, if I move to the right 0.5 and divide that by 1 SD, I get 0.5 SDs. Okay, that's a z-score. What do I want to do for shade norm? We're not, oh, I see, divide, well, no, it's not 68, it's not half of 68, because the curve's not rectangular. right? There are more people in the middle than 34. So what we need to do is shade norm from negative 0.5 to 0.5, which is going to be higher than half of 68 because we have a peak. So clear my draw, shade norm, and I want to go from negative 0.5 to 0.5. And we end up with 30, I have 38.2. So 38% of the men ended up with an 18-inch forearm. Okay, and you see why that's higher than half of 68? If that box was rectangular, then we could cut it in half, but it's not. What's that? No, this one's not more accurate. It will be once we limit the x values. Okay, so the next part says, where are we? So of 68 inches tall, which percent have forearms? So that's 0 SDs. If we look at this vertical strip, well, actually, it's this vertical strip. We are 0 SDs, so the averages are still the same. It's still 68, 18, but our new SD is going to be 1 minus 0.8 squared times 1. So the square root of 1 minus 0.8 squared times 1 is 0.6. So now you do the same calculation with 0.6. So 0.5 divided by 0.6. So now I'm 0.8 SDs to the right and 0.8 SDs to the left. So negative 0.83, negative 0.83 to 0.83. And that will give me, oh, sorry. And you end up with, come on, my calculator stopped working. Oh, I'm on the wrong box. I'm not even, I wasn't on shade norm. So negative 0.83 to 0.8301. And we should get a percentage that's larger. Yep, 60%. All right, that takes care of E.